Alright, this is Module 17, Write and Graph Equations of Lines. We have forms to write equations of lines in. One of these forms we actually use more often than another one. Standard form we use every once in a while, and that's the form where you have a constant number times a times some variable x. It's going to be your input variable, and then plus some constant number b times your variable y equals another constant number c. This is particularly useful when you have to find x and y intercepts, because you can use what's called the cover-up method from Algebra 1. Slope, cover-up method, here we go. Slope-intercept form. You have y equals mx plus b. This form is useful because you can read straight off the slope is the m, the number that is in front of the x, the rise over the run, that is. And b is going to be the y-intercept, where it hits the y-axis. So the main thing is, when your y-intercept, you're always going to have the number 0, comma, whatever that b is. That's going to be your point. And this is the one, again, that is most commonly used. So, it says write an equation of a line in slope-intercept form. Now, there's a couple different, many different ways of actually being able to do this. I'm going to do the one that I think is the easiest. I look and see that my y-intercept right here has the point 0, 4. So that's your y-intercept. So automatically I can say that b is equal to 4. The next thing I have to do is I have to find out what my slope is. And your slope, remember, is rise over run. And you can do it a few different ways. You can actually use the y2 minus y1 over x2 minus x1. But since we have the actual graph here, I can do rise over run. So I can go from this point, I'm going down 2, which would be a negative 2, over 1 to the next point, so positive 1. And it's rise over the run, so this would be a negative 2 over 1. Then I can just plug it into my equation, which is negative 2x plus 4 equals y. And remember, it's the form y equals mx plus b. Where b is your y-intercept, in this case it's 4. And m is your slope, which in this case is negative 2. Now, this is the other way that you can actually do this. You have the slope-intercept form using the actual slope formula. So this is the slope formula, and you can find it by doing y2 minus y1 over x2 minus x1. And this is something we did in the last module, and you've done also in Algebra 1. So this is your x1, this is your y1, your x2, y2, change of y over change in x. And when you do that, you find out you get negative 2. Same deal as what we had before, and then you plug it in, and finding negative 2x plus 4 equals y. And again, it doesn't matter which way you do it. The reason I did it the other way is because I had the actual graph given to me. But that's where the creativity comes in mathematics. You could do it either way you want. Okay, so example 2. Write an equation of a line passing through the point negative 1, 1. That is parallel, that's key, to the line with the equation y equals 2x minus 3. From the last module, you have to recall, what do parallel lines have in common? Well, they have the same slope. So finding the slope, the parallel lines have the same slope. The slope of the line y equals 2x minus 3 is 2. So the slope of the line we are writing the equation for will also be 2. So m is equal to 2. We know that. The other thing we know is that since we know m is equal to 2, we also know the point negative 1, 1. So negative 1 is an x value, and 1 is the y value. So all you have to do now is to plug it into your slope formula. So we know that our slope, we're going to substitute, our slope is 2, or in this case 2 over 1, and we plug in our values and we cross multiply. So again, it's easier, even if you have a whole number, it's easier to write the whole number with a 1 underneath it, so you remember to cross multiply. So when you cross multiply, remember the distributive property, especially with here, with the 2, because that'll be important. What I have my kids do is I tell them to make peanuts. So that looks like a peanut. That looks like a peanut. If you don't eat peanuts, don't get offended. So when you do that, cross multiplication, distributive property, and then you're solving for y, so you have to add 1 on both sides, and you get y is equal to 2x plus 3. They have the same slope. The two lines have the same slope, but they just have a different y-intercept. So this guy up here has a y-intercept of -3, and the one we just figured out has a y-intercept of +3. Okay, writing equations of perpendicular lines. To write an equation of the line J passing through the point 2, 3, that is perpendicular to the line K, with the equation y equals -2x plus 2. Okay, so finding the slope, remember perpendicular lines have a negative reciprocal, so we can automatically say, okay, we know the slope is -2. So if you want to write, just if it helps you, -2 over 1, because when you take the reciprocal and then the opposite sign of it, you'll get 1 over 2. Next, we can use the slope formula again, just like we did in the previous one. We know the slope is 1 over 2. We know it's passing through the point. This is your x, this is your y again, x1, y1. And so we substitute into the slope value. Cross multiply again. So this is again something you did in algebra. So when you cross multiply, remember to distribute. And once you distribute, then you have to solve for y. So in this case, I would add 6 to both sides to give me a +4. And since I have the 2 attached to the y, I need to get rid of it. You divide both sides by 2, and remember to divide each part of the equation by 2, so that you get, this is again, divided by 2, divided by 2, divided by 2, so that you get the proper one. A lot of the mistakes that I see is that people do not divide each one of these by the number that is in front of the y to get rid of it. So once you do that, you have your slope is 1/2, you have your y-intercept is 2, we found the equation of a line that is perpendicular, that creates a right angle with the line y equals -2x plus 2. Okay, so here's another example, real-world example. So we have gym membership. The graph models the total cost of joining a gym. Write an equation of the line. Just to kind of go into a little bit more depth, if you've ever tried to join a gym, they always have something that's called a joining fee. That's one of the reasons why it doesn't start off at 0. So we have cost in dollars and the amount of months that you have spent. Since we are given 2 points, we can take those 2 points and use it to find the slope. So change in y over change in x. Use the following, the previous examples to make sure you have x1, y1, x2, y2. When you do that, change in y over change in x, you get m is equal to 44. Once you have that, use the slope formula and choose one of the 2 given points to substitute and cross multiply, solving for y. The answer you should get is a y-intercept of 143. So the y equals 44x plus 143. And I'm not going into as much depth with this one because we've done a couple of examples that are like it. So you can check and see if your work matches up and you actually get this one. Okay, so this is what I was kind of alluding to. What are the meaning of the slope and the y-intercept in the line? This is just kind of something the initial joining fee I was talking about, because you always have to spend money, whether it's shipping and handling. There's always an initial fee of some sort with most products, I will say. So your slope and the intercept is used a lot in business as well. So the slope actually represents your monthly fee. That's how much is constant, and it's for example, when I was working at a gym, we always had a $19.95 joining fee. But in this case, it's a $44 per month, $19.95 monthly fee. $44 per month monthly fee. That's actually a pretty expensive gym, so hopefully it's a good one. Okay, so this is, again, we're given an equation of a line in standard form. And this is where graphing these lines are actually pretty easy because you use the method called the cover-up method. And so the cover-up method basically says, okay, to find the x-intercept, we're going to cover up the y. So if you cover up the y, that means you get 3x equals 12. And you can solve, and you get x is equal to 4. So that means your x-intercept is going to be 4. So we can put that on the x-axis here. So that's my point, 4, 0. And you can label it just to help you make sure that you're plotting it correctly. Finding the y-intercept, again, you use the cover-up method, and this time we're going to cover up the x value. So that means the 4y equals 12 stays. And we solve, we get y is equal to 3. So once we have that, we just put that on the y-axis, 0, 3. And typically what I see is that people sometimes get mixed up with the y-intercept or y-axis and the x-axis, and graphing the x-intercept and the y-intercept. So what I have my people do is label what the x-axis is and what the y-axis is, just to make sure. Once you do that, you guys have a ruler. You guys can do this better than I, but I will do the best I can. There's my straight line. Semi sort of straight. But you guys can put a ruler through it to make it a little bit easier and nicer. Okay, so we have another example, DVD rental. You can rent DVDs at a local store for $4 each. An internet company offers a flat fee of $15 per month for as many rentals as you want. How many DVDs do you need to rent per month to make the online rental a better buy? This is one of those things, if you notice, in this day and age, we are going very quickly to internet businesses. And even in some cases, we're getting rid of DVDs. So this problem here might be extinct in the next 3 to 5 years, or maybe even sooner than that. But we have renting a DVD at a local store for $4 each. So you have your equation for your rental store is going to be $4 times the amount of DVDs that you rent. So there's your y equals 4x. And for the internet company, you have a flat fee of $15 per month for as many rentals as you want. So in this case, we have y equals 15. And there's no 15x because it's a flat fee. It never changes. You could rent 0 DVDs or 1,000 DVDs. So y equals 15. And if you recall back in a previous module or in Algebra 1, this is a horizontal line. So in order to see this, we can do one of two things. How many DVDs do you need to rent per month to make the online rental a better buy? Well, we need to see, so I'm going to do this visually. So graph each equation. If you graph each equation, you get this guy here, which is the y equals 15, and this guy here, which is the y equals 4x. Now, how do you actually find out this number? Well, that's what's called the break-even point. So, The point of intersection, the break-even point. And the way you do it is you say, okay, y is equal to 15, and that equals 4x as well. So both the y's at this point are the exact same. So you set them equal to each other, and if you divide, you get x is equal to 3.75. So you have to rent 3.75 DVDs in order to make it more lucrative. Problem is you can't rent 3/4 of a DVD, so you probably have to go up to 4.